Let's take a really quick look at parabolas, the vertex, and the shape of them. When you see something like this equation, we know that that's a quadratic, and it's a parabola. But the question is it facing up? Is it facing down? Is it super wide? Or is it skinny? And so let's take a look at this formula here that we write for quadratics and see what do the A, B, and C do for what our shape of our parabola ends up being. Here's a sample. We've got y equals 2x squared minus x plus 5. To find the y-intercept, remember we set the x is equal to 0. These two terms become 0 and we get 5. So it's hitting here at 5. And I'm sorry, all of my parabolas are missing their arrows on their ends. And so for this one, we know it's facing up because of this leading coefficient. But how do we know how fat or skinny it's going to be? Notice this one is much skinnier in scale than the last one was. Well, the difference is this leading coefficient here that's telling it how fast to grow. And so that coefficient is taking the squared term, which is going to square whatever x you have, and that's going to be the biggest number as we change those x's and get larger and larger. And when you square it, you multiply it by 12. It brings this in, so it grows really fast. And then here you see this coefficient of the x squared here is a fraction. And as a fraction, it says, go ahead and you can square that x value, whatever that is, but I'm going to take 2/3 of what you get. And so we end up with this wide-looking fraction. So the smaller the fraction, the wider your parabola ends up being. Here we have one now where that leading coefficient is a fraction, but it's a fraction greater than 1, so that's saying take 1.5 times whatever the x squared is. But this negative sign is telling you to reflect that down across the axis. And that's because whatever your x squared term is here, this is positive, but then you multiply it by a negative and the y values then become greater and greater negative numbers. In general, with our quadratic, the bigger the a is, that's that coefficient of the x term, the skinnier that parabola gets because it grows faster as the x's get larger. The smaller, closer to 0, not smaller going negative, but fractional between 0 and 1, that is going to be wider. Now 0 to 1 is also -1 to 0, you get smaller, but if it's negative, you also get an upside down parabola. The vertex of the parabola occurs here, and what it really does is cut that parabola into two pieces. So we've got this axis of symmetry, sorry, not a straight line, axis of symmetry that gives us this nice symmetric look to our parabola. Sure, it's not drawn over here, but it can keep going in this way. We can find that vertex by using a specific formula. Remember, our quadratics we were writing as y equals ax squared plus bx plus c. And this a and this b give us then what we need here to find that vertex coordinate, so -b over 2a. For the example that we have here, a is -2 and b is 8. So let's find the x-coordinate of the vertex. X equals -b over 2a, so that's -8 over 2 times -2, -8 over -4, so 2. So the x-coordinate here is 2. We can find the y value by taking that x and substituting it back into the formula. -2 times 2 squared plus 8 times 2 plus 5. So we get 2 squared is 4. 4 times negative 2 is negative 8. 8 times 2 is 16, so we get plus 16, and then plus 5. No, I did not do this ahead of time, so 16 minus 8 is 8. 8 plus 2 is 13. So the y-coordinate of that vertex is 13. And that's all you need to find the vertex of a parabola.